Have you ever been given too many options, or have you seen something oversized? For example, people's age varies, so we want to be able to allow a lot of different input for age. But you would not ask somebody, hey, please enter an age between 0 and 2.1 billion. Nobody's going to be that old, not even close. The good news is, if you choose int to hold age, it will hold anybody's age. The bad news is you might be wasting a little bit of space. Now, here's a more reasonable example. You know this big flask can hold more than a completely full graduated cylinder. So, if this graduated cylinder was completely full and you dumped all of the contents into the flask would hold it no problem. When you are certain that one type of container can hold another type of container's contents no matter how full it is, then you are using what is known as implicit casting. Well, variables are containers, and their size is based on the data type that they were created from. Now, in this first statement, we put 10 into a byte. It's pretty small. And you know, that 10 is going to fit into an integer, no problem. Next, we stuff the byte as big as it can go to 255. That 255 will have no trouble fitting into that integer. In a similar fashion, you will have no trouble taking an int and putting that into a float data type. Also, a float data type will easily fit into a double data type. Can you guarantee that this cup will be able to hold everything from this jug? No, maybe it will. You'd have to look first. If this jug is almost empty, then maybe the cup will hold it all. Most likely, this jug would overflow this cup. So in real life, we're always careful when we watch when we're pouring a big container into a little container. Let's look at the C# containers. There's a big container named int, but it's almost empty. It's only got 10. You could fit that 10 into that byte variable. Now, if the int held 1,000, the byte can only hold 255, then the second statement cannot hold that 1,000. Now, to play it safe, C# is going to err on both of these statements because it knows the integer is capable of overflowing the byte. But you can tell C# that you thought it through. This integer, with the value as it is now at 10, is okay to fit in this byte. So we put parentheses byte right before the variable, and we've done an explicit typecast. If you were to put a byte typecast in front of the second line, actually it wouldn't error, but it would do something kind of unexpected. To explain that, let's look at these three different statements. If you put an int as 255, it will just barely fit into the byte, so this typecast will work as expected. The 256 and the 257 will not fit into the byte. If you were to console write-line these results out, this first one would show up as 255. The second one would be 0. This last one, with 257, will turn into a 1. What's going on? Well, imagine you were trying to explain to somebody how clocks work. As time goes on, the numbers get bigger. 10 o'clock becomes 11 o'clock. 11 o'clock becomes 12 o'clock. What's 12 plus 1? Well, it's time to start over. It goes back to 1 o'clock. Think of a byte as a bigger clock. It starts at 0, goes 1, 2, 3, 4, and gets all the way to 255. And if you add 1 to 255, it starts over at 0. That is called overflowing the data type. Let's create a new project, and it will be a C# console application called overflow. Click OK. Now, we're going to start off with doing an implicit cast, which won't overflow at all. We'll say byte called byte val, and we'll set that to be equal to 200. Then we will declare an int, which will be int val, and we will say that is equal to the byte val, which we know is 200. Now, let's console.writeLine the result of the int val variable. And of course, let's pause our program at the end with a console.read key. Let's run this. And we fed 200 into the byte, and the int took the value of 200 from the byte, and we read it out. so it says 200. What happens if we switch this? Well, let's do it with some more code. Let's declare an int, and let's call this myInt, which is equal to 200. Now we'll say byte, my byte is equal to the myInt variable. And now we will console.writeLine the myByte variable results. We know this 200 will fit into this byte, but when we try to run it, we get an error. You cannot implicitly put an int into a byte. But what we can do is typecast it. Put a set of parentheses before the integer variable to typecast it as a byte by putting byte in the parentheses. Now let's run it. And it says 200. Okay, great. Let's change the second one to a value of 255. That'll just barely fit into the byte. And it says 255. Now let's take this 255, my int, and increment it with the plus plus unary operator so it becomes 256. Notice the results say 0. What if we increment it one more time? So 256 plus 1 plus 1. That's 257. But it will overflow the 255 and it gets a value of 1. Just like if it was 12 o'clock and you added 2 hours, you would go to 2 o'clock. Overflowing just keeps counting up. Now, let's create another project called Enum cast. File, new project, Enum cast, and click OK. Now, in the namespace above the program class, we're going to have an enum that has integer as its underlying data called color code. In the main method, we're going to declare an integer and make it 3 because we're interested in green. Let's type int code equals 3. Now we're going to say color code, which is my color, equals color code as the typecast for the value of 3. Yes, of 3. But let's use it of the variable that has the value of 3. Now let's console, writeLine the result. Of course, we want to pause the program at the end with a console.read key. Let's run this. It says green. Now let's change this so my color is explicitly set to red. Color code.red. And now we're not going to initialize the int. Instead, we are going to set the int code variable to be equal to the my color value typecasted as an int. So get the integer from the chosen color. Now let's display the int code to the right line. Red should be the value of 1. Yep, it's a 1. Imagine you handed this package to somebody important in your life and said, "This is a present for you." They look at it excitedly and say, "What is it?" Your answer could be, "It's a box." But you know they're looking for what's inside the box. Let's say that this person is packing a suit for a business trip. To them, it's a suit. But while at the airport, it's just a suitcase. Then they get back to the other end of their destination in the hotel room, and they open up this suitcase, and it becomes a suit. We pack, travel, and unpack. In C#, we can do what's known as boxing and unboxing. And sometimes that object travels from one place to another place while it's inside of a box. To start this example, I'm creating a new console C# application called boxObject. In the main method, create an object called objectInteger and set it to 100. Now, an object could be anything, but this anything seems to be 100, which is compatible with an integer. So let's type integer int val equals the typecast of int of the obj int variable. Now let's do a console console.writeLine, and in the double quotes, we will say casted integer, and then a variable placeholder will grab the value of the int_val variable. Let's pause the program at the end with a console.read key. And it says casted integer 100. So we successfully took 100 that was inside of an object and typecasted that into an integer. Let's do this with a string. Type object obj string equals double quotes hello, and then string strval is equal to the typecast of string for the obj string variable. And let's show the results with a console writeLine, casted string, and the variable placeholder to capture the strval variable. Let's run and test this. There, we see casted string hello. Now, why didn't we just set it as a string in the first place? So we didn't have to get it out. We knew it was going to be a string. Well, sometimes you're partnering with other systems, and everything they're going to feed you is an object. If you know what's inside of that object, you can unbox it and turn it into the data type that you need it to be. Time for Lab 4.1, Skill Check 1. Take a moment to pause this video and challenge yourself to do this skill check. Skill Check 2. Take a moment to pause this video and challenge yourself to do this skill check. Skill Check 3. Take a moment to pause this video and challenge yourself to do this skill check. And that will do it for Lab 4.1 on casting data types. Our next item, Lab 4.2, data type parsing.